Cool. Let's get started. Thanks for joining, and welcome back. Hope you had a good lunch break and are ready for the next session. This webinar, along with all the others, will be recorded, so don't worry, you'll be able to watch it afterwards again if you want to. My name is Christoph Kassen. I work as a solutions architect for AWS here in Germany, and I work with a lot of our startup customers. So I've distilled some of the insights and information I gathered into this presentation about born in the cloud, built like a startup. What can you expect from this session? After the session, I want you to think like a startup when you are deploying your next workload on AWS. And it doesn't really matter if you are actually working in a startup, or if you are just building on your own, or if you're working for a bigger company, let's say Mittelstand, or even an enterprise company. That doesn't really matter. What I'll expect is that you have at least some familiarity with the AWS services. So you should know what Ec2 is, meaning virtual machines. You should have heard about AWS Lambda, API Gateway, these kind of things. If you know the terms, then you're well set to follow this presentation. What are we going to cover? We're going to talk about serverless architectures, and then of course we're going to talk about containerized architectures, and we're going to cover N-tier architectures, the ones we all know and we all have built applications in. So if we look at startups and how startups are approaching IT, then there's four main things that drive the way they work with infrastructure and the way they develop their applications. One of the most important ones probably focus on features. So everyone's trying to build product market fit, making sure that the users love the product, so iterating on features, adding features, A/B testing features, and then iterating to make the product really good so that the market picks up. Along with that, of course, goes the idea that at some point it will pick up and then they need to scale. So they're expecting to scale, grow their business, and along with that, of course, the IT infrastructure and also the team size. In the beginning, everyone's working with a very small team. That's probably just you as a technical co-founder, or maybe 2 or 3 people building the application, and then they need to run the infrastructure. So it's a very lean IT. I wouldn't even call it department, but it's very, very lean. And then last but not least, of course, the lower the cost, the longer the runway, meaning if you spend less on IT, then your runway for takeoff just becomes longer. And these are the 4 core things startups are thinking about. Now, when we look at what the cloud provides, there's another four pillars. There's, of course, security. You just can't afford to be insecure these days. There's breaches being reported, well, almost weekly, unfortunately now. So you need to be secure, and the cloud is giving you that, and is giving you the controls to ensure that you stay secure. Then, of course, you want to be cost efficient, and we talked about the runway. So if your IT infrastructure spend can follow the actual demand, and you do not need to over provision, then you have a competitive advantage. Of course, everybody expects performance and reliability, and these are the other two pillars the cloud provides. Everything's set up in a way that it's reliable and still working really fast. So when I talk to startup customers, the good thing is that they combine all of these 8 things together, and so the successful ones do that in a really smart way. So let's take a look how they are actually doing it and how they are doing it on top of AWS. So what we provide is, we call them building blocks, and you see the areas of the building blocks listed here. We of course provide all kinds of compute, virtual machines, containers, serverless functions in different types and sizes, and you select what you need there. We provide storage and content delivery services, managed databases, and of course networking and security capabilities. But we also provide services to build mobile applications, to manage your continuous deployment pipeline with build tools and pipeline tools to drive your deployment. And of course the whole analytics, big data, machine learning space, with plenty of services such as Elastic MapReduce for managed Hadoop, and many more. Overall, it's 90 plus services, and you need to combine these building blocks in a way that makes sense for your architecture. And I'm going to show you in a bit 3 architectures and show you how you can do that. If you build on top of AWS, you get rid of the upfront expenses. There's no need to buy a service and provision them, but you only pay as you go, priced hourly, or in the future even on a per second basis. So that goes away, the all upfront expenses. And then of course we talked about it already. You can stop guessing capacity. If you scale up, you just consume more resources. So if you have like a peak day, then you just consume more, and then you can turn it off if you no longer need it, or if the Christmas shopping kicks in and you need to scale up for 4th quarter, then you just do that, and you don't need to guess what you might need in a couple of weeks. And with that, you also get rid of the complicated infrastructure management, and you can focus on what's important to your business. You can optimize your product. You can work on features. You can improve the way you interact with your customers, and you don't need to spend time on building out the infrastructure. And you can also go global in minutes. And what does that actually mean? If we look at the map where AWS offers so-called regions, or we call them regions, you see that they're nicely spread out all over the globe. There's a region, of course, in the US, in Europe, also in Asia, in India, and there's many more regions coming online over the course of the next year, as you can see by the green bubbles there. Every region consists of at least 2 availability zones. That's an important construct to remember, because each AZ is completely independent of each other, and that allows you to build your applications in a way that they are highly available, and you can fail over from one AZ to another if you need to do so. And since we're all over the world, you can easily just decide, okay, you're starting out let's say in Germany, so you use the Frankfurt region, but then you want to tackle the US market. So you can deploy very easily to a region in the US and then be very close to your users in the US, so they're have the same speed and feel if they use your application as if they were in Germany. So we talked about the building blocks. We talked about the services AWS provides on a very high level. So now let's dive in and talk about the first pattern, and that would be serverless. So with serverless, you get rid of all the servers. There's no need to provision servers, and that's one of the main benefits of AWS Lambda, which is our service for offering serverless compute capabilities. And if you don't have a server to manage, then you don't need to patch this machine, you don't need to apply operating system upgrades, you don't need to worry about maintenance windows. All these kind of things just go away because they're taken care of by AWS Lambda. And then, of course, it also scales with usage. Just if you invoke the function you deploy to AWS Lambda, the code you deploy there, we call them functions. If you invoke them once, then the function is executed once. If you invoke it 10 times in parallel, then there's 10 function calls executed in parallel. So it just scales up if more requests come in, but you also never pay for idle. If you have a VM running in the middle of the night and there's no users, or if you're just starting out and you just deploy your first prototype and want to see if it actually works, then this machine is running 24/7 unless you of course stop it. But with Lambda functions, you never pay for idle because you only pay when the function is actually executed. And then of course, availability and fault tolerance is built in. So in case something happens, then the function is just executed somewhere automatically because the whole platform is fully managed by us. What are some common use cases for the serverless architecture paradigm? I mean, of course, obviously, websites, now web applications. You can build a very simple static web application and then add some commenting functionality to it if you hook it up with a Lambda function. You can build very complex web applications, but you can, of course, also just build microservices, mobile backends, or Internet of Things applications with the serverless pattern and AWS Lambda. Lambda functions can also be used for data processing, either in real time or with MapReduce or batch jobs. And one of the well, emerging and very popular things people are building with Lambda functions is powering their Amazon Alexa skills. I guess you all know the Amazon Echo and the Alexa voice service. And if you create your own skill, then you can hook up your Lambda functions to this skill so that whenever somebody speaks into their Echo device and calls your Alexa skill, then a Lambda function can be triggered and can execute the action that you want to execute and then return back the result to Alexa. And similar to that, it's the chatbot functionality where you use Lambda functions that are triggered on specific commands whenever the user enters them. And then there's the last part. Within the AWS ecosystem, Lambda functions can be used in all kinds of services to make them make them better, connect them to other services, load data, transform data. All these kind of things are also possible with Lambda functions. So now that we've seen what are the benefits of AWS Lambda and some common use cases, let's take a look at a fully serverless web application. So let's assume we're going to build a React application. So we have the React framework, we have images, videos, all kinds of other assets we need for our application. And then, of course, we have the HTML forming the application, CSS, styling it, and other JavaScript libraries we might be using. All these static assets can be hosted directly on Amazon S3, which makes it very easy to get going. It's very cheap, and it's built for well, plenty of requests accessing static objects. To make it even faster for our end users, we put Amazon CloudFront in front of it, which is a content delivery network. And then our users can access these resources from a domain name, either from their desktop or from their mobile device. And the assets are cached so that the users hit a CloudFront edge location that is closest to their location, so the app loads really fast for them, which is especially important, of course, on mobile devices. Now, of course, we want to add some dynamic elements. We want to make our application tick. We have a backend with custom logic, so we need dynamic requests. And therefore, we use AWS Lambda. To expose the Lambda functions to the outside world, we put an API gateway in front. On this API gateway, we define our endpoints, so /profile, and then we define what kind of operations we allow, get, post, the well-known HTTP operations. And then we can access our API through an endpoint. In this example, it's called api.example.com. And then we can call different Lambda functions. Can be one, can be multiple, depending on how you structure your code. And then the users can directly access this. So our React application running in the browser can simply access our API, but we could also access our API from other services. For example, a Slack webhook, a GitHub webhook, or something similar. Now we have the application running in the browser. We have a backend handling requests coming from the application. Now we need some persistence, and for that we can use Amazon Dynamodb, because it's a fully managed NoSQL data store. And we can access this from either the Lambda functions, or we can access it directly from within our application, since Dynamo is also exposed through an API. And then we can store persistent data there. And we don't need to manage anything with Dynamodb. We just need to create our table, and then we can store data there in the key value format that is well known from the NoSQL world. So now we have a fully serverless web application. There's no server in there we need to manage. There's no patching and maintenance involved. Everything's taken care of. And this is really cool because I can use that to validate my idea. I can just use that to build a prototype. I don't need to worry about service or something that needs to be deployed and operated. So I can quickly go ahead and build and iterate and build my MVP and can launch that to the world. Now, how do you do this best on AWS? Some of you may know that there's all kinds of frameworks for serverless compute. There's the serverless framework, there's Gordon, there's Apex, there's Chalice, there's all kinds of frameworks on GitHub. And there's also the serverless application model that we built. And along with the serverless application model, we offer a tool called SAM Local. We're currently beta testing this. It's also available for free on GitHub. And in combination, this makes it really easy to get started building Lambda functions on AWS. What's cool about the serverless application model, or short SAM, is that it provides all the resources you need to define your serverless API. You define the functions you want to build, you define your API, and you can also define the Dynamodb tables, all within a very simple YAML description. But it also supports anything that CloudFormation supports, and that makes it very, very attractive, because CloudFormation is the tool AWS built for infrastructure as code. So you can define all the resources you want to use on AWS within a YAML template, and then you can set up your complete infrastructure. And then you can repeat all this setup over and over again, for example, in other AWS regions, or in a test environment, in a dev account, so reliably set up the exact same infrastructure you have in production over and over again. And SAM now builds on top of this and just makes it easier to build serverless applications. So I highly encourage you to take a look at the serverless application model and maybe take that as foundation when going ahead and building your first serverless application. Because with SAM, you get the benefit of SAM Local, because it inspects your SAM YAML description, and then you can locally invoke your Lambda function. For example, in the first line, we invoke the ratings functions, and then we provide event data, which is just a JSON object that our function needs, and then processes it. So we just run that locally with the SAM CLI tool that you get once you install the SAM Local package. You can also generate service events. For example, you can hook up a Lambda function that is triggered whenever a new object is uploaded to S3. So you can simulate that locally without the need to upload actual objects to S3. And then, of course, you can run your API gateway locally. So just run SAM Local start API, and then SAM Local spins up a local API gateway, and then you're basically back to the well-known workflow. You write your code in your favorite editor, and then once you press save and send a new request to your API, you'll see the changes immediately. And you can also start it with a -d command and provide a port, and then start it in debug mode, and then you can attach a debugger and locally debug. And that makes it really cool, because then you can really develop offline. You can be wherever in a train without internet connectivity, and still keep working on your application. To make that even easier and to make it better, if you want to work with multiple people, there's a service called AWS CodeStar, and that makes it very easy to quickly spin up a project, because if you go into your AWS console and you look for CodeStar, you'll see that you just have to select what type of application you want to build, and then you select Lambda, and then you execute this template, and that sets up a Git repository for you. It sets up a continuous deployment pipeline. It sets up API gateway. It sets up a Lambda function for you, and that makes it super easy to just get started. And the project you get, if you choose a serverless application, is based on the serverless application model. So you see that all fits nicely together. You have a Git repository with your code. You can check it out. You use SemLocal to develop locally. And then once you're ready, you just git commit and then push, and it's automatically deployed to AWS Lambda and then accessible from anywhere in the world. So I highly encourage you, take a look at CodeStore, take a look at the serverless application model, and then go and build your serverless applications. Now the other topic, of course, we want to cover is containerized architectures. If you take a look at the classic anti-tier architecture, VM-based, you have a load balancer, you have a web server, and you have a database. All that is running on top of VMs. And then you ensure that you have a standby database, you have multiple web servers to handle the load, and the load balancer is distributing load among these. So with a containerized architecture, you basically have the same architecture, except that your applications are now all running within a container, for example, a Docker container. And then they're running on top of container instances which host these Docker images. But what you actually want to do is you want to leverage the features the platform provides. So you want to use the application load balancer from AWS that allows you to send traffic to different kinds of Docker containers, for example, based on the path. So the /login path goes to a complete different set of containers than the /checkout URL, for example. And then you also want to use a managed database. You use RDS, which stands for Relational Database Service, and there you have failover capabilities built in. You have automated and manual snapshots for backup and recovery. You have monitoring built in. So there again, you utilize what the platform offers and utilize that for your advantage. And how do you do that, or how do other startups do that? Is actually pretty easy. First of all, you use the AWS CLI command, and then you log into the container registry. Then once you have logged in, you just use the well-known Docker build commands. So you build your container based on your Dockerfile specification, you tag the image, and then you just push it up to the container registry, which hosts your Docker image securely within your AWS account. And then we provide a service called Ec2 Container Service, or short ECS, and alongside there's a CLI tool to control this service. So you simply configure your ECS cluster, you define where it should be running, you give it a name, you define the size, and you add a couple more parameters, and you can do that either from the AWS console or from the CLI with the ECS CLI tool. And then maybe you already have a Docker Compose file, so you can just use your Docker Compose file and read the service definition from the Docker Compose file, and the ECS CLI tool will take care of reading that and recreating the exact same environment within the ECS service. And then you bring up your services, and you have your containers running, and you have your services defined, and you can access your application. If you have a more advanced specification, then of course you can just provide a JSON file and then let the AWS CLI create all the services. So it's actually very easy to get started with ECS and containers on AWS as well. Well, let's take a look at what that provides once we have executed the commands we have seen before. So we have our containers stored in the container registry. We have container instances where only the Docker daemon is running. And now ECS provides us with a scheduler and schedules the services we have defined onto these container instances. We again use the application load balancer to distribute traffic and to route traffic to different fleets of containers. And then RDS is not part of this service specification. It's just a service outside, but we just utilize that because we don't have to manage this. We don't have to define anything there. We just provide the endpoint to our application, and then our application can talk to our relational database, for example, our MySQL or PostgreSQL. Also, if we host on ECS, we can set up service discovery. We can, for example, create entries within Route 53, which is the DNS service. So our services all become get a DNS endpoint, and then they can talk to each other using the DNS endpoint. And this is also a place where glue code in form of Lambda functions comes in because you can automate all that using a Lambda function. Maybe you have already heard about autoscaling. So autoscaling allows us to scale instances up and down. And this also works for containers. So if we receive more requests for one of the services we host on ECS, then we can simply spawn more containers. And also if the fleet hosting these containers needs to scale as well, then we can also set that up as well. And another benefit is the log files from all the containers are picked up automatically and sent to CloudWatch logs, which is collecting all these logs so we can see what's going on within our containers from a central place. There's no need to log into any of the container instances and figure out if something is broken within the container. We just let ECS take care of that and let it grab the log output and send it to a central place so we can easily see that. So now we've seen serverless architectures, we've seen containerized architectures, but what about the cases where you already have something existing, maybe a third-party application or maybe a WordPress blog you want to use for your company blog or for content marketing purposes, and you want to get that set up and hosted. So we've seen this this architecture before. It's the classic N-tier architecture. We have a load balancer distributing traffic. We have multiple application servers hosting our application, and we have a master database and then a standby database in case something goes wrong. All this needs to be hosted ideally within 2 different data centers so that we have full HA capabilities available. Now, how do startups do this? So let's assume we have our WordPress application within our Git repository, so we can simply clone the repository and then we use the EB tool, which is the command line tool for Elastic Beanstalk. So we initialize our application with the init command, and then we create a production environment. Then this sets up the whole environment, also provides us with a RDS managed database. In this example, it's a Postgres database, but it could also be a MySQL database. And then you just load in the latest dump you have into that database. Then set up some environment variables, so shared keys, database, username, table name, password, all these kind of things that we need to set up. Now, once this environment is defined, we easily can create a clone of this environment. So we simply create a new environment, which is a replica of the production environment, and then we can make whatever changes we want to do to our application, add a new theme, install plugins. And once we've done that, we just git add, and then we commit the changes to our repository. And since this repository is local, there's no need to push them, but we can just run deploy first, which will set up our application within the test environment. So we can safely change major things, and then test them. And once we're ready to go to production, we just switch the environment to prod, and then we just run deploy again, and it will deploy the exact same code version we had in our test environment to our production environment, and then we're live. So what does this give us? Yeah, it gives us EC2-based end-tier on top of AWS. So we have a load balancer integrated. We have EC2 instances hosting our application, and they're set up in an auto-scaling group, so they scale up and down based on the traffic they receive. And then again, we have a relational database, service database, and everything is hosted within 2 availability zones. So in case something happens to zone A, everything is still running in zone B. And then as you can see here, we have the exact same setup in the production environment and in the test environment. So we can really easy test changes before we deploy them to production. Also, we have some other significant advantages if we use Elastic Beanstalk, because we get all the AWS security controls already built in. So we have the identity and access management, which we can use to control who can access the application. So we can define that certain users are only able to access the test application and cannot deploy to the production application. So they can make changes to the test environment, but not to the production environment. We get VPC networking, so we can, for example, put all our EC2 instances and RDS instances within a private subnet that is not accessible from the internet. So it's completely private, and only traffic coming through the load balancer is able to access our application. We also have CloudWatch again. We have the centralized log management, and we also have metrics. So we can see how many requests are coming to the ELB. We can see what's the CPU utilization on the EC2 instances. When is it scaling up? When is it scaling down? We can all see that from a central place, and it's all built in. And we also, again, can use S3. We can use the CDN for faster delivery to users somewhere else in the world. And we can store all our assets, video files on S3 to make them accessible, and that is very cheap storage. So with Elastic Beanstalk, well, you could call it the quickest path to best practices, because that's what it will give you. Best practices are built in from the start, but it also nicely integrates with your developer workflow. So you have a Git repository where your code changes live, so you can do code review before updating the application. And with the Elastic Beanstalk command line interface, you can also easily integrate this, for example, into your build pipeline. So if you have a Jenkins building your application already, then you can simply build a script that will deploy this this application to Elastic Beanstalk, and then update everything, for example, to production if you run the production job. So we've seen 3 patterns now. We've seen serverless architectures, we've seen containerized architectures, and we've seen the classic n-tier architecture hosted on Elastic Beanstalk. Now, let's talk about microservices and how all this fits into what we've seen before. So let's take a look again at the serverless